All right, guys. So pretty short section to finish up today since we're just doing like the last part of it. But today we're going to talk about a natural logarithm. Okay. So we have logarithm, that button on your calculator that says log, right? But then there's another button on there right next to that that says ln, and that is your natural logarithm. So where that comes from, there's a lot of fancy book talk up here. But really, the easiest way to explain that where it comes from is looking at this right here. Maybe. Right there. We'll figure out the board in a minute. But the natural log, what that stands for, it's when you have log base e. It's got a mind of its own today. All right, so log base e, we can actually, lazy mathematicians, we created a button for it. It's just natural log. Okay, so anytime you see that, it's log base e. Okay, that's where it comes from. So the way it's different, if I grab your calculator for me, if I do log of 3, what is that? What do you get? What'd you get, Corbin? 0.477, blah, blah, blah. Okay. What about natural log of 3? What's that? 1.09, blah, blah, blah. So obviously their values are different. What do they mean, though? Okay, yeah, that does go on. You're not wrong. That's just not what I was asking. Like, what is this asking me to find? What does log mean? I want to make sure we understand what that means. Log isn't just, yeah, I push the button, I get a number. Like, I needed to make sure you know what it's asking. What is this asking you? Yeah, this is asking you 10 to what power will give me 3 for an answer. That's what it's asking you. Okay, what's this one asking? Well, what's natural log stand for? That's log base e. So really this is log base e of 3. So that's asking you e to what power equals 3. And they're asking you 2 very different questions. That's why we have very different answers. Okay. The biggest thing with logs is students look at that as like, yeah, I push log, so I don't really know what it's doing. Like, I want to make sure you understand that a log is asking for a certain exponent, right? If there's no base number down here, we assume it's a 10. So it's asking 10 to what power gives me 3. And it's not a pretty answer because it's not a pretty calculation. This one, remember, E stands for a number. Do you know roughly what E stands for? If you're not sure, type in E to the first power on your calculator. Okay, 2.718. E is a number. So this is like 2.718, blah, blah, blah. To what power would make that a nice answer of 3? So obviously, it's going to have a pretty ugly decimal in order to make that happen. Does that all that make sense? Like how this works, right? Logs and natural logs. Where in your calculator? It is right below the log button. It says LN instead of NL. I'm assuming that comes from, different languages, where our language is derived from other languages. All right, so go ahead, just get some button pushing practice. Use a calculator to evaluate each logarithm, round to 4 decimal places. So again, it's in ln, so natural log. What happens when you push natural log? What's it automatically do? Opens that parenthesis for you. So the natural log of 2. So again, it's asking you e to what power is going to give me 2. So it'd be 0.6931 if we round that. And again, it fills your calculator. That means that decimal keeps going forever and ever, okay? It's not going to stop. All right, what about natural log of 0.3? So e to what power is going to give you just 0.3? Ooh, negative 1.20. It wants 4 decimal spots, so what would it be? It would be 40, yeah. Because that would be a 9 on the end, but the 7 pushes up to like a 10 or a 0. So yeah, it's going to go ahead and transfer all that. All right, how about natural log of -1? Why not? Get no real answer. Again, it's asking e to what power gives me a negative number. E is positive, right? Can I take 2 point something and raise it to an exponent and make it negative? Does that make sense? Could I take the number 2 and make it a negative number by raising it to an exponent? No, I can't. So I can't do that one. All right, natural log. Ooh, that's a pretty one, isn't it? Natural log of 1 plus the square root of 2. Good. 0.8814. So the biggest thing that you need to kind of keep in your head, and we're working through these as we get into solving after this into next week, is natural log is log base e, just so we can always remember that. All right, so we'll go ahead, let's practice those properties from yesterday just with natural logs, right? It's a type of logarithm, right? It's just log base e. We just have a fancy name for it, right? The natural log. So on 22, what's the 2 out front become? An exponent on the 15. So I'm going to have natural log of 15 squared. What's the minus do? What's minus mean? Divide. Yeah, it means divide. And I just have a 75. Would you stop there? No. What's 15 squared? Is that 225? Can you simplify 225 over 75? It becomes what? 3. Well, that looks much nicer. Now, will you ever be able to really loopy-swoopy a natural log to have a nice, pretty answer without the log being written there? Because again, it's asking you e to what power is going to give you that answer. Yeah, e is an ugly number, right? It's an ugly 2 point right after that. So that's never going to be able to be raised to a nice, pretty exponent to give you a nice, pretty number. Okay, so those are always going to kind of just simplify as far as you can, but that natural log is always going to be there. All right, how about 23? You write natural log 1 time, and I have 7. What's the plus mean? Multiply. Number in front means exponent, so that's 5 squared. 5 squared we know is 25, and 25 times 7, 175. So all those properties from yesterday, they come right back again today. All right, 24. 24, we have that number in front. Numbers in front always are exponents. So we're going to have x cubed. The minus in between is division. Exponent in front, what does that exponent go to? Both of them. Good. So that's going to be 2 squared and x squared. It goes to both. Now that being said, let's go ahead and clean this up. X cubed over x squared. Yeah, it's going to cancel that and just leave 1 on top. And then the 2 squared still on the bottom, so I'll just write that as 4. About 25. So I'm going to have natural log. Jacob, what's that first one become? 3 natural log of x will be written as, good, x to the 3rd. Let's see. Jonathan, what's the plus sign mean? I'm going to multiply. All right. Carrie, what does the 2 natural log of y, what does that become down here? Marissa, have you picked up what's the plus sign mean? Good. Means I'm going to multiply again. And I just have a 5. Nothing else with that one. Now, I went in order, and that's kind of what it looks like. Does that bother anybody else? Some of you are like, nope, I'm good. I'm going to leave it the way it is. And that's fine. Just me personally, I would write that as 5x cubed y squared. It's not wrong, but the number at the end like that always just drives me crazy. So I went ahead and rewrote it. All right. I added something. It's not in your notes, I know. But I added something. So how do you find the age of your dog in human years? Right? Times 7. Do you have a dog?
Yeah.
How old's your dog? 11. So Marissa's dog. Your dog is 7, you said? Oh, 11. Where did I get 7? There you go. So times by 7, so your dog would be 77?
Yeah. So.
It's an old dog. She's an old dog. She? Anybody else got a dog? Uh-huh. You have 3. Andrea, how old are your dogs? Do you know? You have another dog? How old's your other dog? Okay, well, I'll leave that one there. All right. Who else? Anybody else got dogs? Yeah. 5 years. There's a U in your name, right? You said 5? So 35. Middle age? What? Were you referring to the 35 as middle age? That would assume that you're going to die at 70. Middle age. I'm 37, so when you're like 35 is middle age, I'm like, not that old yet. I got long left. I'm on the downhill. I'm done. All right. So guys, the reason I bring this up, yeah. $40 to $60. Ha! I'm not there yet. All right, hold on. I gotta stop that. I do. All right. This is my dog Sammy. He's old. He's blind. He can't hear anything anymore. He's 14. Okay. So based on like how we used to do it, that would say that he's 98 years old, which I believe it. But he still gets around really well. But with the new way, it's 16 times the natural log of however old your dog is plus 31. According to that, he's actually only about 73. So he's actually a lot younger. I mean, he's still old, but a lot younger than what we originally were thinking. But the reason I brought that up is because let's talk about some of these ages that you guys put up here. So Marissa, so 16 times the natural log, your dog was 11 plus 31. So instead of 77, Marissa, your dog is now 69. So yay, your dog's younger. All right, so Andrea, some of your dogs, let's see, you had an 8-year-old dog in there. So instead of 56, but look what happened. Now your dog is 64.
Whoa. I can't believe it.
Isn't that interesting? To me, that was so interesting that it works that way. But look what happens when you have a 1-year-old dog. So 1 year old, we would say is 7. No, they're saying that's more like 31. Mm-hmm. But isn't that interesting though? And this dog is now like 48. Oop. Hold on, you could do that. If it's a week old, it would be 1 out of 52. Right? Because there's 52 weeks in a year. So if it was a week old, that doesn't work so well because it's negative. I got negative 32.
I got 0.59. Oh.
Yeah, I put it into with that age thing. Yeah. Isn't that interesting, though? I thought it was really interesting. Let's see. So, don't want to leave Courtney's dog behind. Courtney, your dog is more like 56. But, I mean, if you stop and think about it, like the different breeds, yeah, some of them do. But yeah, but some of you guys are 17, 18-year-olds old, and sometimes you act like a 3-year-old, you know? Like, I'm sure I did too at your age, you know what I mean? Like, it's just how we are. But think about a dog's lifespan. Is their lifespan as long as ours? No. So, Courtney, what kind of dog do you have? Okay, I'd be curious what their life expectancy is. Oh, is it the longest one? Okay. I just, makes me curious. It makes sense with my dog. It made sense to me. Now, some of the younger ones, I'm like, is it really? But that's the newest research out there. I just thought it was cool because it had the natural log in it. I'm like, whoo, something like real world that comes into.
I swear my dog's not hungry.
All right. The other thing I wanted to show you guys today is the change of base formula. Yay! Right? No? Okay. Well, let me tell you why we have it, and then maybe you'll be a little more excited. Change of base allows me to use the log button on my calculator to find any answer to any log, no matter what the base is. Now we're a little more excited, aren't we? Yeah, the way this works, because your calculator only does base 10, but this one I can now use to find any of them. So the way it works, yeah, big old fancy thing. So just kind of show you step by step the easiest way. The way this works is whatever your base and your number are here, you take log, it'd be base 10, right, if I just write log. So log of whatever the number is divided by log of what my base number was. So then that allows me to find 4 to the roughly 2.322 power would give me 25. Which is kind of cool because now I can use my calculator. Those of you who were like not so great at the day we were evaluating them, now we can use our calculator to help us out a little bit. So somebody remember one that we did before that works out nice and pretty? So if I had log, no. How about log base 2 of 8? What's the don't type it in. What's the answer? It's 3. 2 to what power equals 8? Yeah, it's asking 2 to what power equals 8. That's what it's asking you. So if I'm using, let's say I had no idea. Marissa wasn't here for this, so she has no idea how to do that. So we could use this formula, right? It would be log of 8 divided by the log of 2. Grab your calculator. Practice typing it in. So log of 8. Now what do you have to make sure you do after you hit 8? Before the fraction, close your parenthesis. You could type the whole thing in the fraction bar, you'd be okay, but we want to close your parenthesis off. Divided by log of 2. Oh, it's 3. Aren't we excited though? See, now you like the change of base, don't you? In case you're not sure, now we can do it. It's all right. All right, so 26. Again, what does the log mean? What is it asking? Yes, it's asking you 2 to what power equals 12. That's what you're trying to figure out. So now there's not a nice pretty one, right? Because 2 to the third was 8, 2 to the fourth is 16. It's somewhere in between there, so I don't know. So we can grab our calculator and do log of 12 divided by the log of 2. Do we want all those digits? No, don't want all those. It's not exact because it keeps going. You're limited for how big your screen is on your calculator. So the 4 decimal places would be 3.58, what? It'd be 50. Oh, that was painful. Because it's got a 49 and then there's a 6 at the end. So I always think of it as 49. So then it rounds up to 50. That's how my brain thinks about it, instead of just that, okay, the 9 rounds to a 10, and then that's a 0, and then that's complicated. 49 rounds to 50. All right, take a look at the next one. What is this asking? Don't just give me an answer. What is this asking you? Good. So that's what it's asking. So log of 16 divided by log of 3. He's going to continue to be obnoxious, isn't he? So 2.5237. That one didn't have to be rounded. And 28. Dakota, what is this asking me? Got to make sure we're understanding what that means. Good. So we'll take log of 22 divided by the log of 5. .92 what? 0.6. Good. Some kids really struggle with the rounding, so if you round to the wrong thing, I'm going to take a point off for it. So we want to be careful there. So I'll take a point off if you round incorrectly. Yeah, so we got to make sure. Yeah, no, I'm going to. I added 2 more to the notes, just so I could be obnoxious and make you write something down. Sorry. So I added 2 more to it. So log base 3 of 27. How did you know that so fast? Because what's it asking you? And should we know that one? We should. Yeah. So, but if you didn't, it'd be log of 27 divided by log of 3, and we'd find out it is just, in fact, 3. Now, what about the next one? What's that asking you? What's it asking?
What is 256 raised?
Now, before you knew how to use your calculator to help you with these, what was that clue I gave you? If you're going from a big number to a small number, it's a fraction because it's doing a root of some sort. So what did you get when you figured this one out? 0.25, which is, good, that is 1/4. So what's it actually doing? It's a 4th root. The 4th root of 256 is 4. But again, before you were like, oh my gosh, I suck at these. Like, I know it's a fraction. What is it? Or the negative number, and like you didn't know what to do with it. Now we can just do the log of 4 divided by the log of 256, and it can do it for us. Yay, right? See, now you're a little happy about that one. All right.